Hello, fall of 2020. So here's a specific video on long and synthetic division that matches up with the worksheets that are in the package. So use long division to express the improper fraction as a mixed number. So, sorry, a little shaky. So 70 goes into 80. Does 7 go into 8? Yes. How many times? Once. 1 times 7 is 7. 8 minus 7 is 1. Bring down the 0. Remember, this is the long division algorithm. 7 going to 10? Yes. How many times? Once. 1 times 7 is 7. 10 minus 7 is 3. So the answer is 80 over 7 is equal to 11 whole plus 3 sevenths. Plus 3 sevenths. Another way to look at that is if we multiply everything by 7, right? We'll get 80 is 77 plus 3, right? So that's a way of showing that that is true, right? That is a true statement. Yeah, that's about all I want to say there. Let's move down. 1205. 51 divide into 1205. So is 51 going to 1? No. 12? No. 120? Yes. Oops. Goes in twice. 2 times 51 is 102. 120 minus 102 is 18. Bring down the 5. Does 51 go into 185? Yes. 3 times. 3 times 51 is 3. And we got a 15 there. 185 minus 3 is 2. 8 minus 5 is 3. 32. So 1205 divided by 51 is 23. So 23 whole things plus 32 51s, plus 32 over 51. All right, with variables, x plus 2. X plus 2 goes into x squared minus 5x plus 7. So the way we treat this, we look at the leading term here, the x, and then we look at the leading term here, x squared. Does x go into x squared? Yes. How many times? Well, x squared divided by x is x. X times x plus 2 is x squared plus 2x. And we subtract. Now this term is just going to go away, the first one always, right? Because we're matching it. And then negative 5 minus 2 is negative 7x. And then we bring down. Okay, same as the long division algorithm, we bring down. Does x go into negative 7x? Yes, negative 7 times. Or another way to do that is negative 7x divided by x is negative 7. Multiply. Negative 7x minus 14. Subtract 7 minus negative 14 is 21. So we got one way to show this, matching, trying to keep these on the same page. So we've got the divisor. This is the divisor in this particular instance, is divided into the polynomial. This is the polynomial, giving you a quotient. This off screen. This is the quotient, and a remainder, and that's the remainder. So divisor, polynomial, quotient, remainder. Okay. And we can state this in two different ways, right? So if we go back up to here, we can say x squared minus 5x plus 7 divided by x plus 2 is equal to, so this is the division statement, right? It's equal to the quotient, x minus 7, plus the remainder, 21 over x plus 2, right? Because the remainder is 21 of these, right? Just as it was up here. It's 32 51s, it's 3 sevenths. So it's 21 over x plus 2. Now a better way to state this is just to multiply everything by x plus 2. So we say the polynomial Okay, now this is a binomial, right? So it gets bracketed times x plus 2 plus 21, right? Now, is this true? Well, we can expand this, right? So this will give us x squared plus 2 minus 5x minus 14 plus 21, x squared minus 5x plus 7. Okay, so there's two ways of stating it, right, which are these two guys here. Question, if. Why is there an if there? if b is this, I guess, I don't know. X minus 1 goes into x cubed plus 3x squared. I'm going to write this. We're going to come back and fix this in a minute. So you might not want to write quite this far if you're kind of following along writing stuff. Is x going to x cubed? Yes. How many times? X squared. This gives me x squared, x cubed minus x squared. And we subtract. Now these are always going to be the same. We're making them the same, right? So these are just going to subtract to nothing. 3 minus negative 1, so we got 4x squared. Now here's the problem. If I bring down a 6, and I say x goes into 4x squared, right, plus 4x times, and I multiply 4x times the negative, I will not get a 6. So we need to make some adjustments when we do this. And here are the adjustments. Okay, now you can write stuff down. There needs to be a placeholder for every power of x. So plus 0x minus 6. Okay, I'll extend that out. So now we can bring down plus 0x. And now we say 4x squared divided by x is 4x. 4x times x is 4x squared. Minus 4x, subtract 0 minus negative 4 is 4x. Right, and then bring down the 6. X goes into 4x 4 times. Don't want to plus it's not a new cough. Plus 4x minus 4, subtract 4x minus 4x. Negative 6 minus negative 4. Make sure your integer arithmetic is good, right? Negative 6 minus negative 4 will be negative 2. That's the remainder. So we can say this two different ways. X cubed plus 3x squared minus 6 over x minus 1 is equal to, so the polynomial over the divisor is equal to the quotient x squared plus 4x plus 4 plus the remainder, right, which is negative 2 of these guys. Now, instead of the plus minus there, then we could read, oops, that's not the eraser. That's not the eraser. That's not the eraser. That's not the eraser. That's the eraser. Okay, so instead of saying plus minus, right, we can just go minus 2 over of these, right? And that's one way. The way I prefer is to state the polynomial. So multiply everything by x minus 1 and say that x cubed plus 3x squared minus 6 is equal to the quotient, right, which must be in parentheses, times the divisor, right, and then minus 2. If we expanded this out, then we'd end up with like a minus. You can see how we're going to get a minus 4 there, and then the minus 2 to give us the minus 6, right? So if we expanded this all out, right, we would end up with a constant term from here of minus 4, and then the minus 2 is going to make that a minus 6, right? So here we'll get an x cubed. Okay, now I'm going to do this, watch this. I'm going to go minus x squared plus 4x squared. So minus x squared is 3x squared. You take the 4x here. Now I've already used that, right, with the thing. So so let's see, I've got the x cubed. Yeah, okay, use that. So now I've got plus 4x. And then from here, minus 4x, which would be 0x, minus 4. Minus 2. I got fancy and probably confused you. Now, let's use synthetic division to get the same result quicker. So here's how synthetic division works. So what we do is, I'm actually going to write the x minus 1 here. And in some methods, you won't actually see them write that. And what we're going to do is put down the coefficients. So a 1 for the x cubed, 3 for the x squared. Now, there's no x, right? But I need a placeholder for it, and it's 0. So if you're looking at this, you would go, this is the constant, the x term, the x squared term, the x cubed term, right? And then you would say, so not, I'm putting my hand over the other thing, which makes no sense on a tablet, but so x cubed plus 3x squared minus 6. All right, here's how synthetic division works. So what we do, we bring down the 1. Whatever is there, we just bring that down. We take this number, negative 1. Negative 1 times 1 is negative 1. Okay, now we subtract. 3 minus negative 1 is 4. And we just keep repeating that process. Negative 1 times 4 is negative 4. 0 minus negative 4 is 4. Negative 1 times 4 is negative 4. Negative 6 minus negative 4 is positive 2. That's a nice put a little line here. That's my remainder. So the way that I read this is, that's the remainder. That's the constant term of the quotient. This is the quotient, right? That's the constant term. That's the x term. That's the x squared term. So I would write this. X cubed plus 3x squared minus 6 is equal to x minus 1 divisor times quotient, okay, constant x squared. This will always be 1 degree lower than this. The quotient is always 1 degree lower than the polynomial. So x squared plus 4x plus 4, oh, that's minus 2, right? Negative 6 minus negative 4 is minus 2, for those of you that were screaming at the screen saying it's minus 2. Right, and where are we here? And you notice how this is kind of paralleling, but without all of the, basically it's collapsing all of this down onto the one line, because we're always making these guys the same, so that they will disappear, right? They won't subtract out. Ooh, a blank page. Oh, nice. I will take the blank page out before I put this in. All right, so that's a quick synthetic division, and I just got to figure out how to stop this video, and we'll be good to go. Alrighty. Let's get me back.